Good morning, Miss E.
Good morning, class. I'm Miss In. I hope you have already watched the last video of Math Olympiad questions, and I hope you like it. Today, I'm going to show you another solutions to Math Olympiad questions, which I found very interesting. Let's begin. Okay, so there are two beetles begin their journey from air in the same directions and at the same speed. One travels along the big circle, the other along the small circle. Given that the radii of the circles are 72 cm and 42 cm, at what point are the two beetles furthest apart? So in these questions, as the beetle is traveling on the circle, so we need to find the circumference of each of these big and small circle. And in this question, the big circle has radius 72 cm. As we know that the circumference, the formula is 2 pi r. So I'm going to put, I will just put big that represent the circumference of the big circle, which is 2 pi, and radius is 72 cm. So 2 pi times 72. That is the circumference, which is the distance that is traveled by the beetle on the big circle to complete one round. Okay, so I'm going to leave the circumference in this form. Next, I'm going to find the circumference of the small circle. So which is 2 times pi. Radius is also 42. So 2 pi r, 2 times pi times 42. So this is the circumference of the small circle, which is the distance that is traveled by the beetle on the small circle to complete one circle. So next, I'm going to put this circumference or distance in ratio. So I'm going to put big to small. And this is 2 pi 72. And I'm going to put distance here. Okay, so as you can see, these ratios can be simplified as both has common factor 2 pi. So I'm going to divide this both side by 2 pi. So divided by 2 pi, divided by 2 pi. Then we will have 72 is to 42. As you can see, 72 and 42 still have common factor, which is 6. So I'm going to divide this two sides by 6. So divided by 6 and divided by 6. Then we will have 12 is to 7. And you can try to imagine there is a diagram which is similar to this, with the big circle with circumference 12 cm and the small circle with circumference 7 cm. And you can interpret this ratio as the beetle on the big circle need to travel 12 cm to complete one round, and the beetle on the small circle need to travel 7 cm to complete one round. Okay, and then the next thing that need our attention is the beetle is traveling in the same direction. Let me highlight this in the questions. Traveling in the same directions at the same speed from the same point. Okay, the next thing that is important that we need to find is how much can each of these beetles travel within the same period of time. And this can actually be obtained from the inverse ratio of the distance. What I mean is, okay, I'm going to put round. Inverse of 12 is to 7 is 7 is to 12. And this ratio actually gives us that the time needed by the beetle on the big circle to complete 7 rounds is the same time that is needed by the beetle on the small circle to complete 12 rounds. Okay, let me put down here. When the beetle on the big circle travel 7 rounds, the beetle on the small circle travel 12 rounds. Okay, this can be verified by finding the distance that traveled by each of these beetles. So for the beetle on the small circle, and to complete one cycle, one round, the beetle needs to travel one circumference, which is 2 times pi times 42. So I'm going to put down 2 times pi times 42. As the beetle travels 12 rounds, so I'm going to multiply by 12. And this will give us 1008 pi. Whereas the beetle on the big circle, to complete one round, it needs to travel 2 times pi times 72 cm. As it travels 7 rounds, I'm going to multiply by 7, and we will get the same result, same distance, 1008 pi. Since the distance traveled by these two beetles are the same, 1008 pi, and they are traveling at the same speed, that's why the time needed by each of these beetles to complete 7 and 12 rounds are the same. Although the number of rounds are different. One bit on the big circle is 7 rounds, on the small circle is 12 rounds, but the distance traveled by them are actually the same. That's why the time needed is the same. Okay, so next thing that is important to find is which is the point these two beetles have to be in order to be furthest apart. So from this big circle, we can see that the point that is furthest from the small circle should be this point, which is directly opposite point A. Which is directly opposite point A. This is the point furthest from the small circle. So, whereas the small circle, the beetle on the small circle, it has to be on point A to be furthest from point B. So for this beetle on the big circle, for this beetle to travel from A to B, this beetle on the big circle has to travel a multiple of half, as AB is actually a diameter. So what I mean is, for example, if the beetle on the big circle travel half round, half circle, then it goes to point B. If the beetle on the big circle travel two half, one half, two half, then we go back to point A. If the beetle on the big circle travel three half are one half, two half, and three half, then it will be at point B. So from here we can see that in order for the beetle on the big circle to travel from point A to point B, it has to travel multiples of half, but not the whole number. For example, half round, 0.5, or 1.5, 1.5 round, or 2.5, or 3.5. And whereas for the beetle on the small circle, it has to complete one round to go back to point A, to be furthest from point B. So for the beetle on the small circle, it has to, the number of circles it has to travel should be a complete, the whole number. So let's come back to this ratio, 7:12. So 7:12. 7 represents the number of rounds traveled by the beetle on the big circle. And we need this beetle to travel from point A to point B. So we need to think of a way to make 7 as a multiples of half. For example, 0.5, 1.5, 2.5, or 3.5. Let's try 0.5. Okay, I'm gonna open another screen. Try this. Okay, 7:12. So 7, let me put down B here, point B here, which is directly opposite point A. Okay, 7. To make 7 as 0.5, let's say, then we need to multiply 7 by 0.5 over 7. So if you multiply 0.5 over 7 to the left side, then we have to do the same thing to the right side. So multiply by 0.5 over 7. But 12 times 0.5 over 7 is not the whole number. So the beetle on the small circle, we do not have the beetle on the small circle go back to point A. So it seems that this way doesn't work. 0.5 round is not the nearest solutions. So how about 1.5? 1.5 round. So for 7 to have 1.5, then we will need to multiply by 1.5 over 7. So for this, we multiply by 1.5 over 7 as well. But it doesn't give us a whole number as well. Okay, so this is also not the nearest solution. So 1.5 round is not the nearest solution. Then next, we try to think of 2.5. 2.5, we will need to multiply by 2.5 over 7. So the other side also multiply by 2.5 over 7. Also, it doesn't give us a complete round. So next, how about 3.5 round? 3.5, 3.5 round. From 7, 3.5 can be obtained from 7 by multiplying 3.5 over 7. So if we do the same thing on 12 times 3.5 over 7, then we will be able to get the whole number, which is 6. So in this case, we will have the beetle on when the time needed by the beetle on the big circle to complete 3.5 round is the same time needed by the beetle on the small circle to complete 6 round. At that point of time, the beetle will be at point A. This beetle on the big circle will be at point B, and this beetle on the small circle will be at point A. That is when these two beetles are furthest apart. So write down when the beetle on the big circle travel 3.5 round, the beetle on the small circle travels 6 rounds. They are furthest apart. That's all for today. I hope you enjoyed the video. If you like my content, please comment, like, and subscribe. Thanks for watching.